Just live in the rat's
Tangled
nest.
nest.
Yeah, the Gordian knot. You're only, if you try to get yourself out, you're just going to tie yourself in deeper.
Yeah, that's kind of what I'm worried about,
Hmm.
except like it has reached a level of chaos that like there's no returning from.
It's like a boa constrictor.
They're
Each time you
less
struggle,
tangled.
it'll just clench tighter.
Boas don't actually do that.
You don't?
No, so they clench all they can and they just hold.
Oh, I thought they waited for you to breathe, and then every time you breathed out, they clenched a little tighter.
So they're exerting as much force as they can. So since it's as much force as they can, if your force outwards decreases, you end up stuck in the smaller space.
Yeah. So every time you
But
breathe out, like that's how they suffocate you,
yeah,
is you breathe out and then they clench a little tighter, or they get your, then you
they
can't
hold you
bring
at the
more
smaller
air.
state.
Yeah, and then you can't bring air into your lungs, and then you suffocate and pass out. What a way to go! Yee.
Yeah.
Guido says, "Don't touch anything. Sound levels are perfect." So what should
Okay.
we do next episode? 666.
So, what we have on the calendar is discussing all the things in the solar system that are meant to represent the underworld.
Ooh, that's a good idea. Okay.
Um, one thing that I found that amused me to no end is the proposed name for whatever Planet Nine is eventually discovered.
Hmm.
The proposed name is Persephone, which I think is in keeping
That's
with,
cool. Yeah.
yeah,
We could also do. I mean, I think that's good, but I feel like it'll be like a little bit of like a laundry list of things. So there's also the axis of evil, and then cosmic horror would be kind of cool, but it would be more of a science fiction topic.
yeah.
So we
So
could
so
talk.
let's bring in the axis of evil as well. Let me write a note down because I will
Sure.
forget.
Hmm.
I'm like afraid to move over here. I'm hiding a world of cables with my hair right now.
It's possible I'm hiding a world of research material, uh, dirty clothes, and gardening equipment around me.
There is a reason that the wall is directly behind me and the rest of the room is in front of me.
Yeah. Okay. We'll do that.
All right. Um, so I have that ready to record. I'm going to check my hardware settings. I had a dog for those of you who weren't around, and Fraser's the only one who was around. So for the rest of you who aren't Fraser, I had a dog undo many of my cables the other day. So I'm still recovering from that mistake. There we go. Let's go with that. All right. In theory, I'm ready.
Okay. Tell me when you're pressing record.
Pressing record on the video, pressing record on the audio.
Okay. I'm also recording on my audio, and it is working.
All right.
Here we go. Astronomy Cast, episode 665, The Age of Reionization. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain, publisher of Universe Today. With me is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. Right now, the American Astronomical Society meeting is taking place in Seattle. And I was watching the beginning of a press conference earlier before we went live, and there is so much JWST science
Yeah,
that's going to come out this week. It's tasty, awesome goodness.
yeah. Yeah, I got up early, got as much of my news organized and out of the way because I just need to be prepared for the ongoing
Onslaught.
tidal wave, the onslaught of news. And normally when the astronomy panels come out, there's a few interesting takeaways, but I can go a day without saying, okay, that's really interesting and we should cover that during the AAS. So, it'll be
Yeah.
a couple. But I'm sure each one is going to be superlative, right? This is going to be the most of this and the most extreme that. And the first time we've ever seen this, and this theory's been overturned. It's going to be a monumental week in astronomy and science. The first time astronomers got a chance to use JWST, and they are going to run with it.
Yeah. Yeah. And we're looking at a couple of decades of this. And what I'm also enjoying is there are some hints coming out that it is being considered if they can reboost HST to allow it to keep working for a little bit longer.
Yeah.
So we might be looking at this nice era of having good coverage from slightly into the ultraviolet all the way in to the far infrared-ish, not too far because they don't have a lot of coolant, but it's a good age for discovery.
The cosmic microwave background radiation tells us so much about the universe, but after that era, the universe went dark. Then, as gas pulled together into the first stars and eventually galaxies, light returned, beginning the age of reionization. And we'll talk about it in a second, but it's time for a break. And we're back. I always had a really hard time wrapping my mind around those early phases from the cosmic microwave background to the dark ages to the age of reionization. So can you explain that process for everybody? And I will finally get it into my head.
I can try. So as the story goes, universe formed. There was massive heat and energy, and for the tiniest bit of time, the universe didn't have any stuff in it. But as it expanded and cooled, particles came into existence. And at a point about 370,000 years after the formation of the universe, things cooled enough that all of the previously free-flying electrons were able to find a hydrogen or helium, or maybe if they were lucky, a lithium or beryllium atom to glom onto. And this process of the electrons joining in with the atomic nuclei allowed the photons that previously had tried to go somewhere and then gotten absorbed and tried to go somewhere and gotten absorbed, allowed them to finally just fly free. And so this moment of the universe cooling enough that atoms could form and photons could fly free is the moment the cosmic microwave background was formed.
And I think, so sorry, before we move on, I just want to sort of put a couple of other notes on that. So the first thing is like, if you could stand there when these electrons, or when these photons are first trying to fly around, what would it look like? What color would it be?
The best way to think of it that I have is you're going to have all the colors, first of all, because this is just like continuum radiation. And it's super hot, so peaking in the ultraviolet. And at the moment that this occurred, it would be kind of like turning off a neon light or a fluorescent light, where you go from having light coming out, but not getting anywhere. So you're standing there, and the photons that are lucky enough to have been created right beside your eyeballs go into your eyeballs. But the light itself can't really get anywhere. It's trapped in this stuff. So it's like being inside the neon light.
Right. But and then the other thing is that we sort of, you described it again. It's like turning off a neon light, but it wasn't instantaneous.
No.
It was a gradual process to go from no light can escape to now light gets to move for a centimeter, now light gets to move for a meter, now it gets to move for a kilometer, and eventually it got to move for light years.
And And it's unclear how fast that process happened. It was something where areas of the universe that had a higher density, well, they also had a higher temperature. And areas that had a lower density had a lower temperature. And those lower temperature regions were the first to be able to go, hi, here's the cosmic microwave background. Now, the thing that always gets me is we talk about how the universe was opaque when all these neutral atoms were formed. But we also say this in the same breath that we say the cosmic microwave background was released, which clearly we can see. So how is it that we're seeing the cosmic microwave background if we now have an opaque, completely neutral universe? And the answer to that is that for the most part, the cosmic microwave background just passes straight through because of its wavelength, which is a bit confusing.
Oh, okay. So like it was a wavelength of light, kind of reddish. Like I always describe it like it's sort of like the surface of a red giant star. That wavelength was the one that could actually make it out further into the universe than other wavelengths. And so we see, and because if you redshift the cosmic microwave background all the way, like right now it's microwave, but if you redshift it all the way back to the beginning of the universe, it's roughly the surface of Betelgeuse.
And so this light is able to, for the most part, make it through. But what's cool is we're finally starting to be able to detect the early moments in our universe where the universe still had pockets of neutral gas, and these pockets of neutral gas are actually causing defects, irregularities in the cosmic microwave background. So we can see the epoch of reionization and before it using the irregularities in the cosmic microwave background.
And so this pushed into the Dark Ages.
Yes.
And so why were the Dark Ages dark?
Well, there was nothing giving off light. So you have two different problems going on. First of all, you have no stars, you have no galaxies, you got nothing.
Right.
And the other thing is you have a cloud of fairly dense neutral hydrogen and helium, and that's going to absorb light that's coming at it once there is light. So you start off with the Dark Ages as there's just nothing giving off light. So then stars start to form, galaxies start to form, and the first ones forming are having some of their light absorbed. And what's cool is we're using this absorption of light as seen in distant quasars to start pinpointing the moment in history that reionization occurred.
And so this term, reionization, like ionization, what is like from a physics course? Actually, you know what? We're going to get into this in a second, but we should have a break.
I'm going to drink some soda. I'm still drinking soda. Sometimes you just need to pause and drink something. Okay. All right, start us again.
All right, and we're back. All right, so give us the physics description of what ionization is and sort of as it relates to star stuff.
All right, so you have your hydrogen nuclei. It has a proton, some number of neutrons, depending on what version of hydrogen it is, and a happy little electron if it's neutral. And that electron has certain allowed energy levels. These allowed energy levels mean that if a photon hits the electron, only if the photon has the right energy level to allow it to jump between the different levels will that electron move. It can be thought of as if you're on a stairwell, you're either on step 1 or step 2. You can't be on step 1.5 unless you have anti-gravity boots, in which case we've broken the analogy. Now, photons come along, and if they have just the right energy level, that electron that absorbs the photon is going to jump to a higher energy level. And if the photon has a high enough energy, that electron's just going to go away. No more electron. And it's that process of removing an electron that's called ionization. Now, with hydrogen, you only have one electron to get rid of. With helium, you have two to try and get rid of that are in their own little energy levels. And so you need more energy to get rid of both of them. And as you have more and more complex atoms, you can have something that's like singly ionized. That means you got rid of one of its electrons. You can have something that's doubly ionized. You've gotten rid of two of its electrons. And if you have a fully ionized iron, it's had a really bad day.
Right, but, with a shell after shell of ionized electrons. So the point being that the electrons are no longer in place around the nucleus; they are free flowing.
Yes.
Around, and it's so that is ionized, and when the electrons pair up with the nucleus to form more, I don't know, stable atoms, but anyway, that is neutral.
They're electrically neutral.
Right, and they are no longer ionized. So. Yes. So we've got these newly forming, we've got all this neutral hydrogen that is left over. So in other words, the universe was ionized, then it became unionized because it had cooled down. And you've got all this, just a soup of hydrogen, neutral hydrogen, where you've got hydrogen with its electron, and then they collapse together in these star forming processes to form these stars. They heat up, and then they ionize their surroundings.
So this is where it gets super cool.
Okay.
Pop 3 stars, which we talked about in the last episode, really, really big. And their high energy photons have an easy time escaping from the core because there's not a lot of, well, in fact, there is no heavy elements in the atmosphere of the star to absorb out those heavy elements and then re-release, not elements, those high energy photons and then re-release them as lower energy photons. So we have population 3 stars forming. They are giving off ultraviolet and even higher energy ionizing radiation. So we have population 3 stars giving off all of this radiation. And this is where dwarf galaxies finally get to do something awesome. Where you have massive galaxies are going to have a whole lot of dense neutral gas around them because more gas to form more galaxy, essentially. The little tiny dwarf galaxies don't have as much stuff around them. So the stars inside of them are able to give off this ionizing radiation that can escape in much larger amounts. 50% of the ionizing radiation in a dwarf galaxy is able to escape the dwarf galaxy. And this light is going to ionize a larger and larger bubble, first around each star, then those bubbles will merge. And then around the galaxy. And now you have all these little dwarf galaxies that are just ionizing a Swiss cheese of growing bubbles of no longer neutral gas.
All right, we're going to talk about this again in a second, but it's time for another break. And we're back. So, I mean, are there some examples of a very similar situation happening in the universe today? Like I think about the bubbles in the pillars of creation. Is that the same kind of thing where you've got this young hot star that is blowing out this cavity and ionizing the gas around it?
It's a very similar physical process. I mean, the science is the science. So when you have a star forming system, you have a giant molecular cloud. First of all, you're not really going to have molecules other than like H2 in the early universe. So you have a giant molecular cloud of all sorts of different gases. And as it collapses down and fragments, these different fragments are going to form stars that are able to blow bubbles around them, including H2 regions, which is the ionized gas around these young stars. So you have the same physics, it's just much more interesting because you're throwing in molecules that can now emit their own colors of light, allowing us to peer through the gas and dust using radio and infrared telescopes.
And so once again, if you could be there, standing in space, a safe distance or maybe an invulnerable distance from the star, this, we talked about this last week, these gigantic stars at the very edge of what is possible for a star, what would you see?
This would be a case of, if you were able to fully protect yourself, it would
Yeah,
be
no
very
problem.
much like being underwater, where your headlight, or in a fog cloud, where your headlight allows you to see a certain distance around you, but beyond that, it's just opaque. So as you're near that one just formed, starting to ionize the space around its star, you have this place where all of the ionizing radiation has been absorbed and done its job, and beyond it, it's just opaque gas, and you
So
have a wall.
wow. And it would be like this, the star would have probably, with its stellar winds, would probably be off the charts. And so it would have cleared out any additional materials. You'd have this empty space.
Yeah.
And then whatever distance where the edge of the bubble was forming, you would have this reionized gas in this giant sphere around the star.
And what
And
starts
those,
get
and if you could somehow navigate, you would see them, these blobs of hydrogen with little gaps inside of them where the stars were forming.
and what starts to get super cool to imagine is, if you're hanging out in one of these bubbles, and this would require time travel because there weren't enough heavy atoms to make anything resembling a civilization. So if you
Yeah, time travel.
time
Yeah.
traveled into one of these bubbles, it would eventually merge with another bubble. So you'd have this window into another area that you could see into that was ionized. And over time, these bubbles would essentially merge with one another, creating a sphere filled with stars. Just like when you look at some star forming regions, you can see that central region. I'm thinking of the Omega Nebula here, that central region that has been cleared out by the star formation and is still surrounded by gas. No dust back then, no dust.
So how long did this period take, do we think?
We're trying to figure this out, and trying to figure this out is a complicated task on two different fronts. So on front one, we need to be able to figure out the expansion rate of the galaxy so we can translate the redshifts, the amount that the different lines being emitted by atoms have been shifted into years, and we also need to observe. What I can tell you is the galaxies that have quasars in their hearts that we've been able to see in the earliest parts of the universe, they're giving off extremely bright light that, as it travels from that quasar towards us, it's going to encounter pockets of gas along the way. And these pockets of gas represent areas that are eventually going to become star formation, the material around galaxies between here and there. And some of them represent not yet ionized clouds of material. And when we look at galaxies at z equals 6, we're seeing pockets of this material. But when we're looking at z equals 5 point something, they've looked at a variety of these systems, and it appears that already at that point the universe was fully ionized. So it was
Can
a
you
very
translate that
fast process.
for the
So,
non-Z? Like, what is a 5.6 or 6? Because I know
so
like 14 is, oh, sorry, like 2017, like these new ones that are coming out of JWST, these are 300 million years after the Big Bang. But
yeah. So we're thinking that all of this occurred between 150 million and 1 billion years
Right.
ago,
Okay.
and trying to figure out exactly when in there it was done. We know it started around 150 million. We know it was done by 1 billion. Where in between those two
Right.
that it was done, we're still figuring out.
And the process, I guess the process is uneven, that you've got
Yeah,
different amounts of gas, different strengths of stars, different size collections, which were probably linked up to overdensities and underdensities in the cosmic microwave background. And so different parts collected together, heated up, cleared out sooner than others.
exactly. And like I said, the really cool thing is the dwarf galaxies literally got to shine. And it was the area around the
Hmm.
biggest galaxies that, because they had so much more material that they had to ionize, the areas around the biggest galaxies took a little bit longer to clear the way.
So, what are our tools to perceive this time?
Well, the best tool that we have is gravitationally lensed galaxies that exist back behind galaxy clusters, and those galaxy clusters help magnify the amount of light that we're able to get, and then we point our infrared telescopes like JWST at those gravitationally lensed galaxies from the beginning of the universe, and we look for quasars. And once we find those quasars, we use them to figure out where in the quasar's history do we see what kinds of material, well, essentially grabbing out the light. This for the collections of gas that are more close by. It's the Lyman Alpha forest. And then we're looking back at the stuff that just hasn't ionized yet.
So, so we're seeing the light of the quasar through the
Yes.
gravitational lens, because only
Yes.
by harnessing the gravitational attraction of an entire galaxy cluster can you make a telescope powerful enough to be able to see this period. You're looking at
Yes.
these quasars, gravitationally lensed quasars, and are you seeing them? You're seeing the light from the quasar go through
Yes.
pockets of gas and dust that are in various states of ionization. You mentioned the Lyman forest. What is that?
So what's happening is you have the background quasar is giving off light, where Lyman alpha is one of the easier to spot lines of light. Now, that Lyman alpha uh, gas, that in the emission lines can allow us to figure out where quasars are. Now, the quasars, in addition to having this entire suite of emission and absorption lines, also have the continuum radiation that they're giving off. That continuum radiation, as it travels towards us, is going to have the hydrogen gas, pockets of hydrogen gas, absorb out different colors depending on where in history they are. So the light that was absorbed out at 2 billion years after the Big Bang by hydrogen gas is going to be redshifted to be one color. And that is a Lyman alpha line that has now been redshifted into a color we can detect from the
Right.
ultraviolet into the reds.
Right.
From a different age, it's going to have a different wavelength. So we have the continuum radiation from the quasar that is going to have this forest of what was hydrogen Lyman alpha absorption lines from an entire suite of different points in history where there were clouds of gas located to absorb the light. Now,
So
what's
the light from this quasar is going through multiple gas clouds, and
yes.
you're seeing the forest with all
Now,
of these trees.
Now, those forests that you're seeing aren't the not yet ionized gas left over from the Big Bang. That actually gets its own name, which, as someone with dyslexia, I have to be careful with because it's called the Gunn-Peterson trough, and my brain has decided it should be the Peter Gunn trough, which would be far more amusing.
Right. Right. Right.
So the Gunn-Peterson trough is this gap that we can see, a literal trough in the light from the most distant quasars that is there from the neutral gas that wasn't ionized in the beginning. And this is what we're desperately looking for using JWST, so that by finding enough faraway quasars with these Gunn-Peterson troughs, while Peter Gunn plays in the background, we are able to say, okay, so we're seeing these troughs in quasars at these specific points in history, and then we don't see them anymore. That tells us everything was ionized by this point in history.
Very cool. And as we mentioned at the beginning of the show, be prepared. There's probably going to be a bunch of news coming out about the Age of Reionization just in this week's American Astronomical Society. So hopefully now you will be better able to understand it. Like me. I think I get it now. So I think we're all right.
I'm so glad.
Nice.
It's not easy.
Yeah. All right. Well, thanks, Pamela.
Thank you, Fraser. And I need to thank our wonderful patrons who are out there supporting this show. You allow us to pay all of our humans and, where needed, provide them with health benefits. And that is kind of awesome. This week, I would like to thank by name Burry Gowen, Stephen Veit, Gordon Young, Kevin Lyle, Jeanette Wink, Nano Flips, Bora Andre Livsvol, Andrew Poelstra, Venkatesh Chary, Brian Cagle, David Truog, Gerhard Schwarzer, Buzz Parsec, Zero Chill, Laurel Kedison, Robert Plasma, Jack Mudge, Les Howard, Adam Anise Brown, Joe Holstein, Frank Trippin, Gordon Dewis, Richard Drum, Alexis Wanderer, M101, Felique Scoot, N through Sets, William Andres, Gold, Roland Vormerdam, Jeff Collins, and Simon Parton. And all of you who join our Patreon will have access to an ad-free version of all of our episodes. So if you're noticing ads in the episodes, go join Patreon.
Do it. Join us. Thanks, everyone. And we'll see you next week.
Bye-bye. And then they saved.
Don't go anywhere. But you all knew that by now.
Yeah. And we are going to be recording the episode that should be recorded on Monday on Wednesday instead, so that episode 666. And this is because Monday is Martin Luther King Day here in the States. And I'm going to my first public event since I just lost Fraser. Where did Fraser go? There's Fraser. You went away.
My internet went offline for a second.
That was terrifying.
Yeah. All right.
So I'm going to my first public event since COVID hit. It is the Aresia conference. He went away again. I'm going to finish my sentence while he comes back. I'm going to Aresia in Boston, which is an event that is requiring that you have both vaccinations, both boosters, and the bivalent booster. And it is also requiring masks, or they boot your butt out the door. And I'm adding Fraser back in.
The internet.
Dropbox killed your internet?
Dropbox killed. I'm gonna see if I can duplicate the error. Okay, I'm gonna go to Dropbox right now. Bye.
You're still here.
Hold on.
Your lighting is so much better though when you have Dropbox open.
Hold on. All right. Weird. Okay. My lighting is great. You just like everything super bright.
I like things with more contrast. And now you look slightly orange. You look less orange.
That's because I'm now looking at you. It's just a reflection. You see yourself in my eyes. All right. Now I'm uploading. Everything's going to be fine.
I'm going to see what questions we might have over on Twitch if you want to look at YouTube.
Yeah. No questions. So, they get a rant.
Okay.
All right.
Are you getting rained by all of the climate change induced, what is it, Pacific rivers that are like
Mm-hmm.
drowning Northern California?
Yeah, but not so bad. Like,
Okay.
I've seen worse bomb cyclones. I've seen worse atmospheric rivers. This is fine. We got 30 millimeters of rain yesterday. That's adorable. Like
That's
100 millimeters of rain. That's a big day. Like when we get 100 millimeters of rain,
that's a
the
centimeter.
river overflow. No, it's 10 centimeters.
You're right. I can't math today. Ignore
Yeah,
me. Ignore me.
yeah, yeah. So yeah, we get 10 centimeters of rain. That's when the creeks overflow. That's when roads start to wash out. That's when places start to flood. If it matches up with a king tide, it gets. But it's been fine. In fact, it's been nice and warm. We still can't get our car up our driveway yet. But I think I like our chances in like 3 days. Like I think 3 days the rain will have cleared off the snow that I can actually drive my car back up and park it in my house. Because right now the car is parked down at the bottom of the road.
I,
Go ahead.
I feel like you need to put in a driveway that has really big grooves to provide you extra traction. Like not a flat driveway, a purposefully grooved driveway.
Yeah, that would just be covered in snow and then the snow would turn to
Okay.
ice. No, I like I need a tractor. And like I'm resisting this with all my will because I don't want a tractor. Like a tractor just sounds like a random collection of metal problems. Diesel, I got to maintain the diesel and I don't want it. So but the guy who does our snowplow quit this year. So nobody on our mountain got their driveways plowed. But
Procyon MSC wants to know if you're still toying with Starlink.
I haven't canceled my Starlink account, but I will. I should.
Okay.
Yeah, yeah. Or like lend it to my dad while he waits for his fast internet.
Yeah, that sounds like a good thing to do. You want your
Yeah,
dad to be able to video conference.
yeah. But yeah, no. But there's like an electric tractor, which is really cool. Actually, like
Yeah.
runs a long time and seems pretty simple. And I'm digging the idea. But you can't just like buy like here. You just get like a Kubota tractor, and then it's got a snowplow attached on it. But the other option is like a quad with a snowplow
Yeah.
on it, and that's pretty cool. A lot of people do that, and so you quickly snowplow your driveway. As long as you can cut off like a chunk of the snow, then it melts quicker when the melt
Yeah.
comes. So so that's the key, as opposed to leaving it. And the worst is when idiots drive up our driveway looking around and they pack down all the snow into ice, and then that takes a lot longer. Anyway,
Yeah.
so here's my rant,
Okay.
which is so last week I mentioned I read the book Revelation Space by Alistair Reynolds, and it was so good. Like it was just like it's the new hotness. I am so stoked with the Revelation space universe by Alistair Reynolds, and it is Mass Effect. So if
Okay.
you enjoy Mass Effect, if you love the Mass Effect universe, you love the underlying ideas and thoughts and the history of Mass Effect. Have you played Mass Effect?
No.
Okay.
But I know our producer, Ellie, she has played it many, many times
Right.
and I've listened to her.
Yeah, Mass Effect is my favorite narrative video game ever. It's so good. And the gist is that humanity joins a council of various races, and together they uncover this horrific secret about the universe, and your job is to try and prevent things, set things right. And as people know, I really like the Three Body Problem series because of the ideas. And Revelation Space has the same level of ideas as Three Body Problem, if even more so, but it has better characters. Like it's just like the characters are great, and so the funny thing is, like, and so I'm doing the book review thing with my
Yeah.
question show. So people go to my Goodreads forum, suggest books. I'll pick a book that I want to read and I'll read it. And so people recommend these books that are the beginning of a series. And so now it turns out I was like, oh, I finished the end of Revelation Space. That was such a good book. man, I just want to be in that universe forever.
And
then
you
I'm like, oh,
can.
and there's 3 more books.
Yes.
So now you recommend a book to me. You have actually, if you're successful, you've begun me now reading a series. So I will, maybe I bang through the one book in a week. This is my whole month, is reading this one series. And so if you're not into that, too bad. This is on you. And by you, I mean the viewer, the reader, the recommender. So
Have you read Calculating God by Robert Sawyer?
no, I've read a ton of Sawyer books though. I read Accelerando.
His Hominid series is super cool.
Yeah, Earth. You read a book called Earth, I think. He's great.
So
Forward is
I'd
great.
recommend next, I know I'm not on your list, I'm not on your Goodreads, but Calculating God is another one of those trying to figure out the reality books that it belongs on that same shelf, but a couple books down from Three Body Problem.
Yeah. Quadlibet, yes. Yes, it is the book with the inhibitors. So that's the series. And for those of you who played Mass Effect, imagine it's the Reapers. But weirder and cooler and scarier than the Reapers.
So as a complete change of topic, since you mentioned video games, Drebsdorf would like us to know Kerbal Space Program is free on Epic Games this week, and Sishu says Calculating God is equal to Take Me to Your Paleontologist. and that is a really good summary of the book.
That was good. Yeah. Kerbal Space Program. You don't have it.
Go get it.
Yeah, and like just in general, like if you are a video game enjoyer, if you sign up for the Epic store, they give away like a new game couple of games every week, and really good titles. And then Amazon Prime, if you go on Twitch, you'll get free unlocks for various games, so you can build a pretty sizable game library without actually having to pay any money. And then if you just go on top of that and you buy the Game Pass from Microsoft, you get access to a bazillion games.
And then there's Humble Bundle, which you're giving money to good causes while buying games. And I'm still bitter about Civilization. 6 is not a good game. Do not buy Civilization 6.
I canceled my Humble Bundle. I had a Legacy Humble collection.
Yeah.
And I just canceled it because it was like, even though it was only like $15 a month and you're getting 12 games and some of them are very good, I just wasn't playing them. And yet there were games that I wanted to play that had just not gone into bundles. And I sort of realized that, okay, just wait for the sales, buy the games I want on sale and play them. And that's been working out really well for me. I've been playing, what did I play? I play Hades. So, and that's the other thing. So I've got the Steam Deck. It's all I use. I only play on the Steam Deck. I don't play on my PC anymore ever. I just play on the
Minecraft.
Steam Deck.
I Minecraft on a real computer so that I can like surround myself, and I know I could do that on a Steam Deck. I just haven't done that on a Steam Deck.
Have you got it? You've gone, don't you?
Yeah.
Like you have to sort of force yourself to play your games on the Steam Deck. But once you do, it's so great. Like I've been playing a ton, way too much. I need an intervention level of time playing Project Zomboid on my Steam Deck. And like the game is so good. It is like if you really want to manage your inventory and take things out of some boxes and put them into other boxes, Zomboid is your game. But and every now and then a zombie breaks into your house and tries to bite you on the neck while you're reorganizing your library.
Project Zomboid.
Yeah. But I played on the Steam Deck, and it's the controls are great. The gameplay is so great, and it's so wonderful to be. I can hang out beside my wife, play on the Steam Deck, and she's reading or whatever. Yeah. Like if you haven't put your Steam Deck to its paces, like dog food it. Like just go, okay, I'm going to play Minecraft on the Steam Deck. I'm going to play, I'm going to pull a game from my library or pick up a game that people just love. Like Vampire Survivor. You played Vampire Survivors yet?
No, I'm adding these things to I've been Minecrafting my brains out. I have to admit to that.
That's great, right? But like Vampire Survivors is such a low brain power game, but it is just really satisfying, and it's cheap. You can buy it for $5 or something, $3, but
It's a shooter up.
it's
I'm
not a
not.
shooter. It's not a shooter.
It
You
look.
are. It's not. You are this character who is walking around, and you've got various weapons that happen automatically, and then you
Okay.
pick up things, and then as you pick up the things, they modify the effect around your character, and so it starts out with very simple, and it turns into just this kind of technicolor vomit on the screen that is
That's what I'm seeing.
your doing somehow. and you wanted this, and it's just a great game, and it's got like tons and tons of unlocks, and it just works so effortlessly on the Steam Deck. That's the key. And then the other game that I got for the Steam Deck is called Hades, which is interesting because it relates to Persephone and to Pluto.
Oh.
And so you are the son of Pluto, or the son of
Mm-hmm.
Hades. Yeah, you're the son of Hades. I forget your name. Anyway,
It's a
um,
dungeon crawler.
it's not a dungeon crawler. It's a rogue like. So you are attempting to escape Hades to go to Olympus, and
Okay.
so each time you do a run through the underground, you pick up various things and sort of upgrade your character. That then comes on to the next run, and you then at the same time you're learning new secrets and you're learning more lore, and they've really nicely balanced this game is punishing, but then you're learning more about the game, and you're also making yourself a little more powerful. So the things that used to be punishing are no longer punishing, and now new things become punishing to you that you couldn't
Yeah.
have reached before. And so at the beginning, you meet this boss, and she's one of the Furies, and she just mops the floor with you. And then you build a few more upgrades. You come back to her and you defeat her, and then after a while, you defeat her. You just swat her as you run
Yeah.
past each time you meet her, and then you get to the next one, and you figure out how each of these bosses work. And so it runs on this loop. Like, I'm sure like a really skilled Hades player could just start and just go right through the whole game in about an hour.
Wow.
But it's but you have to build up to understanding. And so there's this neat idea where you're always sort of reaching the very edge of what you're capable of, but it just plays like a dream on the Steam Deck. So yeah,
I
I'm
tried Deep Rock Galactic and had this reminder of how bad I am at first person shooters.
yeah.
I'm remarkably bad at first person shooters like Valheim, Don't Starve Alone,
Mhm.
Minecraft. I have, oh, what's the one where
I
you're
haven't played
building
Valheim yet.
factories? Valheim is like,
Factorio.
yeah, Factorio. That's another
Yeah.
one where like people who love me said, "Don't do this. We will never see you again."
Yeah.
But
I've got it. I
Valheim
haven't played it.
is like a better graphics, more death version of Minecraft.
Yeah. Yeah, and I've heard what's interesting about Valheim is that you're starting at different technologies, and you're
Yeah.
attempting to use the technologies to defeat the boss and to move on to the next island with with more advanced technologies. And so there's this progression, and that's something that I always like. Minecraft is fine, it's cool, but I always found it sort of pointless.
So they're starting to add in more bosses. There's still the underwater fortresses that
Hmm.
are an easy way to die by Guardian. There's the fortresses in the Nether, but they've started adding these deep, dark fortresses with different creatures you have to attack. And I luckily am on a server with a bunch of people who are far better at killing things than I will ever be. I treat it very much like a game of Legos where I build stuff and then populate it with villagers. Yeah, I'm not
So
a shooter.
well, I'm not a shooter either. I like a strategy game,
Yeah.
or I like a simulator game, I like a war game. I'm not a fan of shooters, and I'm definitely not a fan of bullet hell games. Like, I really don't like that level of coordination where you're trying to, like, Cuphead. People love Cuphead. I see that and I just want to have a nervous breakdown, right? Because it's just so much going on the screen. But I'll play, like RimWorld. I think I'm at 1,200 hours at this point of RimWorld,
Wow.
and I'm like, like, I don't want to toot my own horn, but I'm really good at RimWorld. Like, I can, I put it on the hardest mode that I can, and then I just sort of play the game. And it's challenging, but it's definitely anything easier is for me not a challenge. And I've got like 1,000 hours of Europa Universalis. I've probably got 500 hours of Don't Starve. So
Yeah.
those kinds of games I really like. And Zomboid is going to be gigantic. Although I suspect it's gonna run out for me because it has no point. Like the game begins saying this is how you died, and then it's just inevitable till you die. And so it's just a matter of time before you get bit or you get scratched or you make some horrible mistake. And then if you could if you can get it to easy mode, which a lot of people do, you're just living in your bunker forever. Growing your crops, trapping your rabbits, and never really getting risked. Quad Libet is saying, ever tried Stellaris? Yeah, I've got like maybe 400 hours into Stellaris. It's a good game. Stellaris is the 4X, the explore, expand, exploit. I don't know what it is. The space game by Paradox.
Yeah.
And so it's this cool, start with a single world, build up your fleet, meet other civilizations, trade with
Yeah.
them, wipe them out,
That one's
and
on my
eventually
list to play. I haven't started
it's
playing it yet.
it's really good. And it started out pretty shaky. It started out like a mediocre version in the genre, and then they went back and stripped the game back down a couple of times
Okay.
to revise it, and the new version is pretty good, quick, like pretty streamlined, and has like a really nice progression from early game to late game, and with really cool science fiction-y elements. So you can build
Okay.
later on, you're building Dyson spheres and tapping energy sources beyond the cosmos and discovering ancient, and it's really cool because like in the beginning of the game you'll come across, say, some ring world, or you'll come across some leg race like a precursor, and they will smash you if you get in their face. And so you spend your time sort of like a mouse sneaking around them, hoping that you won't raise their ire. But later on, you come at them, right? And you're like, your technology, your fleets are enormous, your technology is dominant, and now suddenly this thing that haunted you for most of the game is now under your boot, and it's just more territory for you to conquer. It's a really good game, and
That's cool.
it plays a lot of those same kinds of ideas in Mass Effect and Revelation Space, and these space opera ideas. The thing that Paradox does really well, and for example, you were talking about Civilization 6, was you've got you can run away with the game.
Yeah.
Like, you get to a point where suddenly your technology is so dominant, you're smashing.
Right. Right.
But with Paradox games like Europa Universalis, the game drags you back in with technological parity. So in other words, you're making discoveries in technology, and that makes it easier for your opponents to learn your technology. And so they can decide to not invest in technology and instead just wait to hear from you.
Okay.
And so you're always, there's no great advantage to trying to rush forward and become completely dominant, because there are these factors. Like, the more powerful you become, the more your enemies will band together to stop you. And I mean, to see real world examples of this, right? You see what like what's happening with Russia invading
Yeah.
Ukraine, is the world is saying that's not right.
Right.
And we're coming together. And so when you're playing Europa Universalis, this happens to you. You get a little too big for your britches, and suddenly 15 nations come together to stop your aggression. And all the time, and they've all been learning your technology. So anyway, it's a neat way to balance the game. Quad Libet is saying 6,753 hours. That's crazy. Of RimWorld. And Quad Libet, the new version has shelves. I know you haven't played since April 2020, but shelves in RimWorld now. You can pile up stuff more densely than you could before. So that alone, gates,
So
fences.
Mythtown is saying that you might like 7 Days to Die.
Played it.
Okay.
Yeah, yeah.
Did you like it?
I mean, yeah. So 7 Days to Die is sort of like a cross between Zomboid and Valheim. So it's a first person version where you're running around collecting stuff together, and every 7 days the zombies rise up and make an, like there's some event and they come at you, and so you have to build up the defenses to be able to hold back the horde for when they come, and
Oh.
then you have 7 more days of calm, and then on the seventh day they come again in a bigger wave, and it just keeps ramping up as you
Okay.
attempt to survive. And yeah, it's a really good game. um and people have made a mod for Zomboid that's like that, and that brings that back to me, because I know I can feel it. Like, I know when I get to a point I will trivialize the game, I'm gonna have to search for solutions in mods, because you're like, this is easy, right?
Yeah.
Like, build, mathematically, you min max. You heard this quote that, given the chance, players will optimize the fun out of the game.
Yeah. Yeah.
Yeah.
I yeah. What I like about Minecraft is you can optimize out the grinding by building farms for things so that you can
Hmm.
focus on the building and then the going off and attacking wardens and stuff. But
And you can even optimize like harvesting rock and stuff, can't you?
oh yeah. Well, I
Yeah.
don't know about I think you still have to dig.
Yeah,
But
you
like
can't make a machine that digs.
no.
Okay.
But like we've had gold farms, iron farms, uh all sorts of different stuff. I built a zombie farm so that I could recharge things with mending. Um, yeah, so you go through the grind of building the farm, and then you don't have to go through the grind of where's their iron.
Hmm. Yeah. Well, Factorio is the sort of extreme version of that, where everything is automatable, and then also in Dwarf Fortress, for example, which just came out on Steam, they finally
Hmm.
gave a graphic overhaul to it. You can automate things to the nth degree, and it's kind of amazing. I've watched this video. This guy had like tapped a magma chamber and then moved the magma into under his fortress so that he could use it for heat and as a way to dispose of enemies as they attempted to cross his bridge.
I can't wait until people start trying to do that in real life.
I can. We're not all supervillains, Pamela. All right. We're going to wrap things up here. So just a few reminders. One, I'm going to be doing my question show today at 5 o'clock. So
Hmm.
in 5 hours from now. So if you want, come join the show. Weekly Space Hangout is going to be on Wednesday. We're going to record a special episode of Astronomy Cast on Wednesday. Same bat time.
Yeah, same
Same
back
bat
time,
channel.
same bat channel.
Okay.
And over on the CosmoQuest Twitch, we will be live not just on Wednesday for Astronomy Cast, but on Tuesday and Thursday, taking a look at all of the news coming out of the AAS.
Awesome. Okay, great. Then here ends the episode.
All right.
Thank you, everyone, for
So,
watching us, both on YouTube and on Twitch. Thanks to all of our moderators. Thank you to Pamela for bringing the brain. And thanks to all of the behind-the-scenes team who edit and process and text revise this show to success. We couldn't do it without you. Thank you, everyone.
and we will see you next week or on
All right.
Wednesday, actually.
Yeah,
Bye.
we will see you in 2 days.